Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Okay, this chapter is about elements in group 17. So we'll start off with the general characteristic of group 17 elements. So the elements involved in group 17 is fluorine, chlorine, bromine, iodine, and astatine. So we will, to memorize this thing, you just have to memorize Fuyo. Cindy is my name, okay? Fuyo, Cindy's brain is awesome, okay? Then you can memorize the whole thing, okay? But our syllabus only focus on three things, which is chlorine, bromine, and iodine, okay? Why we don't focus on this thing? Because the characteristic is a bit different from this three, okay? You might need to take down. Okay, so in group 17 elements, we have 7 electrons in the outer shell. The elements are all typical non-metals with similar chemical property. When we mention about chemical property, that means they have similar number of electrons. Okay, and they all exist as diatomic molecule at room temperature. Meaning to say they will exist in Cl2, bromine, Br2, and I2. This is known as diatomic molecule. And they exhibit a range of oxidation state. What is the range? It will be from -1 all the way to +7. That means it could be -1, it could be 0, 1, 2, 3, 4, 5, 2, up to 7. Okay, -1 to 7. So they have a big range. But with exception that fluorine is always -1. When we say fluorine is always -1, it means that it can only gain 1 electron. Negative means gain. Can only gain 1 electron. Why fluorine can gain electron? Why can't it lose the 7 electron? That is because the size of the fluorine is too small, that it can only gain electron. It can't lose electron. When the size of fluorine is so small that the 7 electrons, outer electrons, are all tightly bounded to the nucleus. So it's very hard for them to lose. Okay, now let's take a look at the physical property of group 17 elements. So in this group 17 elements, we will have 3 types of elements that you have to memorize, okay, which is chlorine, bromine, and iodine, like what I've mentioned just now. And the color in room temperature is important. Color at room temperature. So for chlorine, it appears as yellow gas. For bromine, it appears as either orange or brown liquid. For iodine, it is either a black solid or it can sublime to purple vapor. Iodine doesn't have an aqueous form. I mean, it doesn't have a liquid form. It does dissolve in aqueous to form yellow or orange or brown solution, but the pure iodine liquid doesn't exist. Okay, I repeat again, the pure iodine liquid doesn't exist. We only have iodine dissolved in aqueous, dissolved in water. So that is not I2 aqueous, okay? It will be in another form. So let me erase this. So it will be either solid or purple vapor. So in terms of physical state at room temperature, for chlorine, yes, it will be in gas. For bromine, it will be in liquid. For iodine, it will be in solid. But when the temperature is slightly higher, it will vaporize to purple vapor. Okay, and in the color in organic solvent, what does it mean? I'm sure you have done something like that in your practical. You might be forgetting. Okay, now let's say I add bromine. Okay, this is your bromine, liquid bromine. Okay, and you're going to add another layer of our organic solvent, such as CHCl3, chloroform. So the moment you have added in, you shake this thing, and eventually it will form two layers. Okay, so the organic layer, what will be the color of the organic layer later? Okay, so for chlorine, it will be yellow. For bromine, it will be brown. For iodine, it will be purple. Is this table important? Yes. Everything in this table are past year questions in paper 2, where they actually gave you this table and asked you to fill up. Okay, now let's move on. The elements have simple molecular structure. Molecular structure. Solid and liquid halogen, sorry, typo, yeah, halogen. No, oh, no. Correct. Okay, solid and liquid halogen consists of X2 molecule held together by van der Waals forces. Okay, or you can write induced dipole forces. It is the same force. Okay, now let us study the trend of the physical property going down the group. Okay, there's a typo here. This is trend down the group. So for atomic radius, what are the things that we have to focus on going down the group? You see, going down the group, there will be one more shell of electrons. Therefore, there will be more shielding. Whenever there's more shielding effect, what happened to the size? It increases. Okay, the first atom has one shell, two shell, okay? Then we'll have three shell, then we'll have another more shell. So it gets bigger. Okay, so next we talk about ionization energy. What is the definitions for ionization energy again? It is the energy required to remove 1 mole of electron from 1 mole of gaseous atom. Means this thing is talking about removing electrons, the ability to remove electrons. Okay, so as the atomic size increase, the outer electrons are further away and better shielded from the nucleus. So therefore, less ionization energy needed. Means as the size is getting bigger, it is easier to remove the electron. Hence, the ionization energy decreases. Okay. For electronegativity, now I want you to write down the definitions. The definitions that causes 2 marks, okay, that worth 2 marks is the ability to attract electron in a covalent bond. Okay, so it's the ability to attract electrons in a covalent bond. So now we're going to comparing the Cl2, which is small, and the fluorine that is big. Okay, so Okay, so can this, sorry, not Cl2 and I2. All right. Okay, so can they gain electron easily when the size is small or the size is big? Which one can gain electron easily? It should be the one smaller size because it is closer to the nucleus. So electronegativity of this is high, but electronegativity for this is low because it's further away from the nucleus. So therefore, electronegativity decreases. Melting point and boiling point. As the size of the molecule become bigger, what types of forces that we are looking at when talk about melting point? So see, if we talk about Cl2 and Cl2, compared to the biggest, which is iodine and iodine, that's very big. So we are focusing on the intermolecular forces between the molecule, and that intermolecular forces is affected by the number of electrons. Okay, so therefore, as the size of the molecule become bigger, the van der Waals forces, or we say induced dipole forces, or we can say van der Waals forces, become stronger due to increased number of electrons. So this is the keyword. So because of that, the melting point or boiling point increases. Okay, now we are moving to volatility. Definitions of volatility will be tested. So I want you to write down. It means the ability to evaporate. The ability to evaporate. So when we want to discuss on evaporations, volatility, melting point or boiling point, we always focus on these types of forces, which is the induced dipole or intermolecular forces. Okay, so here, as the size increase, there will be more electrons. So therefore, there will be increased strength of van der Waals forces, and therefore there will be a stronger attraction. So therefore, volatility will increase or decrease? It will decrease. Okay, you take note of this.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.